So in this video, I'll discuss the concept of the non-PV work. Tapos magde-derive din ako ng mga panibagong state functions which are the Helmholtz free energy and the Gibbs free energy. Okay? So start muna tayo dun sa definition. So non-PV means wala tayong changes sa pressure and volume kapag ka nagpa-perform tayo ng particular work na to. So this is not a result, therefore, of expansion or compression processes. So as an example, we have electrical and chemical work. So yung electrical work, this is due to the flow of current and this is due to chemical reactions. Parehong non-dissipative energy to. These are directed energies pero hindi sila compression or expansion. Okay? So paano natin i-apply yung concept ng non-PV work sa thermodynamic systems natin or sa mga thermodynamic equations natin? So babalik tayo dun sa first law. So according to the first law, we have du is equal to dq rev plus dw. So, yung dq rev, we already have an equation for this. Okay, from the second law, ds is equal to dq rev over t. So, makakonvert natin to into a state function just by doing this. So, dq rev is equal to tds. So, substitute na natin siya dito. We have du is equal to tds minus pdv. This particular equation is for purely reversible and purely PV process. Okay? Paano kapag hindi siya purely PV process? So, ang gagawin natin, okay, de-define natin yung dw. So, if dw is a combination of PV and non-PV processes, gagamitin natin yung definition na to. Okay? So, substitute natin siya dito. Okay? So, we now have du is equal to tds minus pdv plus dw na non-PV. Okay? So, magsiset tayo ng mga conditions para ma-derive natin tong particular term na to. Okay? Para ma-define natin siya. So, by doing this, okay, isa-set natin yung conditions at constant temperature and volume. Mawawala yung ating PV work kasi dV is equal to 0. So by doing that, we have du is equal to TDS plus the dW na non-PV. So equating this to dW non-PV, we have du minus TDS is equal to dW non-PV. So since these two terms are state functions, ibig sabihin, itong dW natin ay state function din. So let's define this. So the dW non-PV is equal to the derivative of u minus ds, which is the same as this. Kasi kapag ginawa mo yung derivative niyan, we have d of u minus ds equals du minus tds minus sdt. Since constant yung temperature, according to this, okay, we have du minus tds, which is equal to this. Okay, so ma-define na natin yung ating non-PV work, which is dA. So, yan yung kanyang symbol. Okay, so dA is Helmholtz free energy, or A. Okay, the A here is the Helmholtz free energy. So we define A as the non-PV work at constant temperature and volume, or A is equal to U minus ds kapag symbols. Okay, so we already have another state function, which is the Helmholtz free energy. So paano naman kapag iba yung conditions? Halimbawa, constant temperature and pressure. So we will use the concept of enthalpy. Okay, from the definition of enthalpy, we have the H, which is equal to U plus PV. Okay, so the derivative dH is equal to du plus the derivative of PV. So dinefine na natin yung du kanina. This is equal to TDS minus PDV plus dW non-PV. So ito yun kanina. Okay, so sinubstitute natin siya dito. Tapos we have the derivative of PV, which is VdP plus PdV. So makakancel yung negative PdV and PdV na positive. So ito yung result niya. dH is equal to TDS plus VdP plus the non-PV work, which is dW. So, isa-set natin yung conditions at constant temperature and pressure para mawala yung VdP. Okay? So, ang matitira dyan ay dW non-PV equals dH minus TDS. So, ililipat natin yung TDS dito para maging dH minus TDS siya. Since dH and TDS are both state functions, state function din yung ating dW at constant temperature and pressure. Okay? So, ayan, yung ating magiging conclusion dyan. So, i-define na natin yung non-PV work at constant temperature and pressure. We have dW na non-PV is equal to the derivative of the difference between H and TS. Confirm lang natin to. d of H minus TS is equal to dH minus TDS minus SDT. So, again, constant yung temperature. So, pareho lang yung magiging result. Okay? So, this particular symbol, dG, is called the Gibbs free energy. So the Gibbs free energy is the non-PV work at constant temperature and pressure. So we now have 2 additional state functions sa ating collection ng mga state functions. Actually, this is the last state function na i-discuss natin dito sa Chem 111. Okay? So now, since meron na tayong definitions ng ating dA and dG, pwede na tayong makapag-derive ng mga equations for du, dH, dA, and dG in terms of these 4 state variables: temperature, volume, pressure, and entropy. Okay? So, syempre, meron na tayong definition for du. du is equal to TdS minus PdV. So, in this equation, u is a function of S and V, or the entropy and the volume. So, ds and dV kasi yung changing dyan sa ating du. Okay, so now let's proceed to dH. So dH is the derivative of u plus PV, which is du plus PdV plus VdP. So, i-substitute natin yung du sa equation, which is this one. So, du is TdS minus PdV. We have now dH is equal to TdS minus PdV plus PdV plus VdP. So, makakancel yung ating PdV. So, we have now dH is equal to TdS plus VdP. So, this is the second fundamental equation. Okay, so in this equation, we have H as a function of the entropy and pressure. Okay, so now let's go to dA, or the Helmholtz free energy. So from the definition, we have the derivative of U minus Ts, okay, which is du minus TdS minus SdT. So substituting du again, okay, we have dA is equal to TdS minus PdV minus TdS minus SdT. So makakancel yung ating TdS. Okay, so the fundamental equation for A is dA is equal to negative SdT minus PdV. Okay, so in this equation, A is a function of temperature and volume. So finally, we have dG. The definition for dG is equal to the derivative of H minus Ts, which is equal to dH minus TdS minus SdT. So substituting the value or the equation for dH, which is this one, TdS plus VdP, okay, we have dG is equal to TdS plus VdP. This is the dH minus TdS minus SdT. So, makakancel yung ating TdS. Okay? So, matitira dyan ay dG is equal to negative SdT plus VdP. Okay? So, in this equation, ang ating G ay function ng temperature and pressure. So, now, the following equations, yung 4 na dinerive natin, ay tinatawag na fundamental equations of thermodynamics. So, for du, we have TdS minus PdV, dH is equal to TdS plus VdP, dA is equal to negative SdT minus PdV, while dG is negative SdT plus VdP. So, our state functions are now functions of state functions as well. So, yung S, yung V, yung pressure, and yung temperature are all state variables. So, wala na tayong path functions dito. Okay? So now we have derived the 4 fundamental thermodynamic equations, du, dH, dA, and dG. So, in-express natin sila in terms of P, T, V, and S. Okay? Since alam natin na yung P, T, V, and S ay mga state variables, therefore, yung du, dH, dA, and dG are state functions. Okay? And if they are state functions, it follows that they are exact functions. So, talking about exact functions, we need to recall a certain property. This is an important property. Okay? So recall that for an exact differential, df, which is a function of x and y, we can express df in terms of the total derivative with respect to x and y. Okay, so na-derive na natin to last time. Okay, so if m is equal to the change in f with respect to x at constant y, and n equals the change in f with respect to y at constant x, it follows that the change in m with respect to y at constant x should be equal to the change in n with respect to x at constant y. Okay, so this is the important property for exact functions. So, dapat magpa-follow dito yung 4 nating fundamental thermodynamic equations. Okay? So, let's start by deriving the relationship for du. So, for du, we have TdS minus PdV, which makes u as a function of S and V, kasi changing yung dV and ds dyan sa equation. Okay? So, now we can write du as total derivative with respect to both S and V. So, after nun, we can compare the two equations. Okay? Yung change in u with respect to s at constant v natin can be equated to t kasi ayun siya. Okay? Parehong ds. And this variable here or coefficient there, the change in u with respect to v at constant s can be compared to negative p. Okay? Equal siya dun sa negative p kasi parehong may dv doon. Okay? By comparison. So, if we follow the rules on exact differentials, okay, we have this relationship. Okay? The change in u with respect to s at constant v differentiated with respect to v at constant s should be equal to the change in u with respect to v at constant s differentiated with respect to s at constant v. Okay? So therefore, the change in the temperature with respect to the volume at constant entropy is equal to the negative of the change in the pressure with respect to the entropy at constant volume. So this is called the Maxwell relation. So yung Maxwell relation, nire-relate niya yung P, T, V, and S in the absence of U, A, H, and G. Wala na siya sa picture, yung apat na yan. Ang nangyayari na lang, nagkakaroon lang tayo ng relations with respect to these four variables. Okay? Which makes it more interesting kasi sila naman talaga yung measurable variables dyan. So this particular Maxwell relation is the Maxwell relation for U. Okay? Kasi galing siya sa fundamental equation for U. Okay? So punta naman tayo dun sa enthalpy. So enthalpy dH is equal to TdS plus VdP, which makes S a function of S and P kasi nag-change yung S and P dyan. ds and dP sila. So we can then express dH as a total derivative with respect to S and P respectively. Okay? So comparing the equations, we get yung change in H with respect to S at constant P, it's equal to T kasi pareho silang ES. Okay? And this one, okay, change in H with respect to P at constant S is equal to V. Kasi by comparison, you can see that they are both multiplied by dP. Okay? So since the equation is exact, the following holds. Okay? Yung change in H with respect to S at constant P differentiated with respect to P at constant S, it should be equal to the change in H with respect to P at constant S differentiated with respect to S at constant P. Okay? So therefore, we have the change in the temperature with respect to pressure at constant entropy equals the change in the volume with respect to the entropy at constant pressure. So this is now the Maxwell relation for H. So this is for H because it came from the fundamental thermodynamic equation for H. Okay? So now, i-derive naman natin yung Maxwell relation for A. We use the fundamental thermodynamic equation for the Helmholtz free energy, dA is equal to negative SdT minus PdV. Since changing ang iyong volume and temperature, A is therefore a function of your temperature and volume. So pwede natin siyang i-express as a total derivative with respect to both the temperature and the volume respectively. So comparing the equations, okay, we get that the change in the Helmholtz free energy with respect to the temperature at constant volume is equal to negative S, while the change in A with respect to the volume at constant temperature is negative P, as we can see here. Okay, so it follows that the change in A with respect to the temperature at constant volume differentiated with respect to the volume at constant temperature is equal to the change in the A with respect to the volume at constant temperature differentiated with respect to temperature at constant volume. So since nag-hold ito, therefore we have the change in the entropy with respect to the volume at constant temperature is equal to the change in the pressure with respect to the temperature at constant volume. So this is the Maxwell relation for A. Okay? So then, let's derive the Maxwell relation for G using the fundamental equation dG is equal to negative SdT plus VdP. Since nakita natin nag-change yung temperature and pressure dyan, G is a function of temperature and pressure in the equation. So we can write, okay, dG in terms of the total derivative with respect to the temperature and pressure. Okay? So comparing the equations, we get that the change in G with respect to the temperature at constant pressure is just negative S, while the change in the G with respect to the pressure at constant temperature is V. Okay? So it follows that the change in the G with respect to the temperature at constant pressure differentiated with respect to pressure at constant temperature is equal to the change in the G with respect to the pressure at constant temperature differentiated with respect to the temperature at constant pressure. Okay? So therefore, the change in the entropy with respect to the pressure at constant temperature is equal to the negative of the change in the volume with respect to the temperature at constant pressure. Okay? So this is now your Maxwell relation in G. Okay? So, in summary, we have the four Maxwell relations. So, magagamit natin itong mga equations na to para ma-derive yung mga parameters na hindi natin na-elaborate sa first law of thermodynamics. Like, for example, the mu Jt. Okay? Meron kasi tayong parameter doon na H with respect to the pressure at constant temperature. So, makakapag-elaborate na tayo ng mga ganitong klase ng coefficients. Okay? May express na natin siya in terms of P, T, V, and sometimes S. Okay? Matatranslate na natin siya doon. Also, the Joule expansion coefficient. So, magkakaroon tayo ng mas elaborate na equations for that. And we can now describe other parameters in terms of these four more measurable state functions. Okay? So now, na-derive na natin yung apat na fundamental equations and yung apat na Maxwell relations. So, paano naman natin sila matatandaan or mare-recall ng mas mabilis. Okay? So, we can use the thermosquare. So, this thermosquare or the Vat Hooke shape is a convenient way to recall these 8 equations without rederiving the whole thing from the non-PV concept. Okay? So, paano natin ginagamit ang Vat Hooke shape or yung thermosquare? So, unahin natin yung fundamental equations. So, alam natin na meron tayong 4 na fundamental equations. So, these are U, H, G, and A. So, lagyan natin dito. Okay? So, yung mga katabi nila, for example, yung katabi ng U sa side na to ay yung S and V. Yun yung kanilang mga independent state variables. Okay? So, this is S and V. It means that U is a function of S and V. Pwede mo nang isulat yung U in terms of the total derivative with respect to S and V. Okay? So, yung H naman ay function of S and P. Yung A, since katabi niya ay V and T, A is a function of the volume and the temperature. And yung G naman ay function ng pressure and temperature. Okay? So, katabi niya yung T and P. So, hindi natin kailangan ng total derivatives. Kailangan natin yung fundamental equations. So, paano natin magagawa yun? So, dun sa, for example, U, makikita niyo yung S, okay? Naka-point yung arrow from S to T. Okay? So, if the arrow is pointing away, okay, this is positive. If the arrow is pointing towards the variable, it's negative. Okay? And the other end of the arrow is the variable that is multiplied to this. Okay? So, for example, in this one, okay, this is T ds. Okay? So, du is equal to T ds. Okay? So, hindi pwedeng S dt kasi ito yung independent state variable ng U. Okay? So, since yung isa ay dv, okay, kasi this is ds, this is dv. Yun yung ibig sabihin ng independent state variables. Yun yung nag-change para mag-change yung state function. So, ibig sabihin, meron kang ds and dv. So, yung t, yun yung nasa other end ng arrow. Okay? And since away from s yung arrow, positive yung value. Dito naman ay towards v yung arrow, so negative. So, yung nasa kabilang end ng arrow ay p dv. Okay? So, that's how you write u. Doon naman sa dh, okay? So, let's just erase muna para mas malinis. Okay? Okay? So, for h, we have positive to kasi away from p yung arrow. Positive din to kasi away from s yung arrow. So, that's positive dp and positive ds. So, yung nasa kabilang end ng arrow for ds ay t. So, positive yan. Yung nasa kabilang end ng arrow from p ay yung v. Okay? So, that's for dh. So, for dA naman, let's erase ulit. Okay. For dA, makikita natin na parehong papunta sa v and p yung arrow. So, parehong negative. Okay? So, yung nasa other end ng arrow na to, that's negative p dv. Okay? Tapos, yung nasa other end ng arrow na to ay s. Okay? So, that's negative s dt. Again, a is a function of v and t, so that's dv and dt. Tama naman tayo dito. Okay? So, doon naman sa dg, okay, we have papunta sa t. Okay? So, negative, tama siya. And palayo naman siya sa p, so this is positive. Okay? So, that's dp and dt. Okay? Since palapit sa t, yung arrow nyo ay dapat ito ay negative. Okay? So, that's s dt kasi ito yung nasa kabilang end. Since palayo naman sa p, that's v dp. Okay? So, that is the fundamental equation for G. So, meron na tayo ng 4 na fundamental equations. So, paano naman yung Maxwell relations? So, ang gagawin nyo lang, okay? So, clean ulit natin. Susundan nyo lang yung ganitong klase ng frame. So, yeah. Okay? So, for example, you want a Maxwell relation for U, dito nyo ilalagay yung intersection sa U. So, paano nilalagay itong ating frame? So, ilalagay nyo lang siya dito. Okay? Pag ganyan. Patagilid. Okay? Yan. Ganyan. So, yung intersection ng dalawang arrows ay nandun sa side ng U. Kasi kailangan natin ng Maxwell relation for U. Okay? So, susundan nyo lang yung bawat isang direction ng arrow. So, for example, this is sulat ulit natin yung arrow. Okay? So, this is partial of P with respect to S at constant V. So, There. Tapos, yung kabilang arrow naman, okay, so erase lang natin. Yung kabilang arrow ay partial of t with respect to v at constant s. So, ngayon, titingnan naman natin kung yung isa sa kanila ay negative. So, kapag kinat nyo to, okay, so symmetric siya with respect to the intersecting arrows. Pero hindi siya symmetric with respect to the middle intersecting arrow. Okay? Ito yung dalawang intersecting arrow na kinonstruct natin. Symmetric siya dyan, pero hindi siya symmetric dito. Kasi yung isang side may arrowhead, yung dalawang nandito ay wala. So, hindi siya symmetric dun sa gitna. Ibig sabihin, some or one of these terms should be negative. So, lagay ko na lang dito. Kasi pareho lang. Okay? So, ganyan yung unang Maxwell relation or the Maxwell relation for U. So, paano naman kapag H? So, ililipat lang natin yung orientation ng intersecting arrows. Okay? So, since gusto natin yung sa H, pag ganyan. Since symmetric na siya, with respect to both the intersecting arrows, yung nasa gitna at saka yung nasa gilid, positive pareho to. So, partial t with respect to p at constant s, okay, is equal to partial v with respect to s at constant p. Okay? So that is the second Maxwell relation. That is the Maxwell relation in H. Yan yung madederive nyo kapag ginamit nyo yung DH. Okay? So next naman ay yung Maxwell relation with respect to A. So pag sinulat natin, again, okay, symmetric siya with respect to both the arrows. Okay, yung nasa loob at nasa labas. So parehong positive yan. So that's partial of S. Okay? Partial of S with respect to V at constant T is equal to the partial of P with respect. So now, na-derive na natin yung apat na fundamental equations and yung apat na Maxwell relations. So, paano naman natin sila matatandaan or mare-recall ng mas mabilis? Okay? So, we can use the thermosquare. So, this thermosquare or the bat hook shape is a convenient way to recall these 8 equations without rederiving the whole thing from the non-PV concept. Okay? So, paano natin ginagamit ang batog shape or yung thermosquare? So, unahin natin yung fundamental equations. So, alam natin na meron tayong apat na fundamental equations. So, these are U, H, G, and A. So, lagyan natin dito. Okay? So, yung mga katabi nila, for example, yung katabi ng U sa side na to ay yung S and V. Yun yung kanilang mga independent state variables. Okay? So, this is S and V. It means that U is a function of S and V. Pwede mo nang isulat yung U in terms of the total derivative with respect to S and V. Okay? So, yung H naman ay function of S and P. Yung A, since katabi niya ay V and T, A is a function of the volume and the temperature. And yung G naman ay function ng pressure and temperature. Okay? So, katabi niya yung T and P. So, hindi natin kailangan ng total derivatives. Kailangan natin yung fundamental equations. So, paano natin magagawa yun? So, dun sa, for example, U, makikita niyo yung S, okay? Naka-point yung arrow from S to T. Okay? So, if the arrow is pointing away, okay, this is positive. If the arrow is pointing towards the variable, it's negative. Okay? And the other end of the arrow is the variable that is multiplied to this. Okay? So, for example, in this one, okay, this is T ds. Okay? So, du is equal to T ds. Okay? So, hindi pwedeng SDT kasi ito yung independent state variable ng U. Okay? So, since yung isa ay dV, okay, kasi this is ds, this is dV. Yun yung ibig sabihin ng independent state variables. Yun yung nag-change para mag-change yung state function. So, ibig sabihin meron kang ds and dV. So, yung T, yun yung nasa other end ng arrow. Okay? And since away from S yung arrow, positive yung value. Dito naman ay towards V yung arrow, so negative. So, yung nasa kabilang end ng arrow ay P, dV. Okay? So, that's how you write U. Doon naman sa DH, okay? So, let's just erase muna para mas malinis. Okay? Okay? So, for H, we have positive to kasi away from P yung arrow. Positive din to kasi away from S yung arrow. So, that's positive dP and positive ds. So, yung nasa kabilang end ng arrow for ds ay t. So, positive yan. Yung nasa kabilang end ng arrow from p ay yung v. Okay? So, that's for dh. So, for dA naman, let's erase ulit. Okay. For dA, nakikita natin na parehong papunta sa v and t yung arrow. So, parehong negative. Okay? So, yung nasa other end ng arrow na to, that's negative p dv. Okay? Tapos, yung nasa other end ng arrow na to ay s. Okay? So, that's negative s dt. Again, a is a function of v and t, so that's dv and dt. Tama naman tayo dito. Okay? So, doon naman sa dg, okay, we have papunta sa t. Okay? So, negative, tama siya. And palayo naman siya sa p, so this is positive. Okay? So, that's dp and dt. Okay? Since palapit sa t, yung arrow nyo ay dapat ito ay negative. Okay? So, that's s dt kasi ito yung nasa kabilang end. Since palayo naman sa p, that's v dp. Okay? So, that is the fundamental equation for G. So, meron na tayo ng 4 na fundamental equations. So, now let's recall the 4 Maxwell relations. So, how do we recall the Maxwell relations using the thermo square? So, for example, we need to recall the Maxwell relation that can be derived from the fundamental equation du is equal to TdS minus PdV. So, ano kayang Maxwell relation yung madederive natin dyan? Gagawin lang natin, magdodraw tayo ng ganitong figure over the thermo square. Okay? So, yung figure na yan, makikita nyo, nasa side ng U, yung dalawang arrows na to. Okay? So, titingnan muna natin yung symmetry. Okay? So, symmetric siya with respect to the figure that is outside the thermo square, pero asymmetric siya with respect to the arrows that are intersecting inside the square. So, ibig sabihin, okay, kapag dinrawing na or kapag na-figure out na natin yung Maxwell relation, yung isa sa kanila ay negative. Okay? Yan. Kasi asymmetric with respect to the inner intersecting arrows. Okay? So, ngayon, what are the involved variables? So, susundan lang natin yung mga arrows. So, dun sa pataas na arrow, we have partial of p with respect to s at constant v. Okay? So, dun naman sa pababa na arrow, partial of t with respect to v at constant s. Okay? So, ito na yung Maxwell relation for u. So, paano naman yung Maxwell relation for h? So, same lang din yung gagawin. Okay? So, magdadraw lang tayo ng figure na yung arrows, okay, nagmi-meet siya dun sa side ng h. Okay? So, symmetric siya, okay, yung line na yan, with respect to the inside and the outside arrows. Okay? So, dapat magdadraw ka nung line na yon na gagawin mong, or i-divide mo yung arrow na nasa labas symmetrically into 2 parts. Okay, dapat laging symmetric yung pag-divide mo dun sa arrows na nasa labas. Tapos, i-determine mo lang kung symmetric din siya with respect to the intersecting arrows inside. Kapag symmetric, ibig sabihin, parehong positive. Pagka asymmetric, yung isa sa kanila ay negative. Okay? So, tingnan na natin. So, unahin natin tong arrow na to. Okay? So, that's partial t with respect to p at constant s is equal to partial v with respect to s at constant p. Okay? That is the Maxwell relation for H. So, tingnan naman natin for A. So, for A, drawing lang ulit tayo ng arrows. So, magdodrawing ulit tayo ng line, okay, na magdi-divide dun sa arrow outside into 2 symmetric parts. So, makikita natin na yung arrow din sa loob ay symmetric din. So, ibig sabihin, parehong positive yung dalawang terms. Okay? So, sundan lang ulit natin yung arrow. That's partial of s with respect to v at constant t. Okay? Is equal to the partial of p with respect to temperature at constant volume. Okay? So, since symmetric, again, walang negative dun sa mga terms. Okay? So, finally, we get the Maxwell relation for G. So, for G, we have this figure or arrow. Okay? So, again, magdodrawing tayo ng line intersecting the outside arrows, okay, into 2, or dividing the outside arrows into 2 symmetric parts. Okay? So, since this arrow inside is not symmetric, or the line did not divide the arrows inside into two symmetric parts, negative yung isang term. Okay? So, hindi siya symmetric, again, kasi nandito yung arrowheads sa isang side, tapos walang arrowheads yung nasa kabilang side. Okay? So, tingnan ulit natin. So, that's partial S with respect to P at constant T. So, yun yung pataas na arrow na to. Equal siya sa negative ng partial of V with respect to T at constant P. Okay? So, ngayon, meron na tayo ng apat na Maxwell relation. So, this Maxwell relation is with respect to A, or Maxwell relation for A. This is the Maxwell relation for G. Okay? So, using the thermosquare, na-derive natin yung apat na fundamental equations and yung apat na Maxwell relations. Okay? So, dun sa mga susunod na videos, I will derive other parameters using the thermosquare or the fundamental equations and the Maxwell relations. So, makakapag-derive na tayo ng mga mas elaborate na equations from the first law. Okay? So, see you next video.